Okay, so we hopped over to 8.7. So we did 8.1 through 8.5, and we're doing 8.7. These are the only sections we're doing in chapter 8. So these are all the only sections that are going to be on our chapter test. So this one's functions defined by equations. So we're going to be learning about functions, which this is kind of what we're, the introduction to functions, okay? So we're going to do some definitions. Relation. What is a relation? A relation is any set of ordered pairs and the ordered pairs are x, y. So it's any set of ordered pairs is a relation. Whereas a function, I wrote this one because I knew y'all probably wouldn't want to write the whole thing out, and I want you to kind of think about it for a second. Function, it's a relation, okay, which we just defined what relation is, in which the relationship between two sets, our two sets will be the domain and range, is such that each member of the domain corresponds to exactly one member of the range. Well, let's define what domain and range are, and then I'm going to basically give you a short, kind of like a easier way to think of what a function is. So domain is the input of the function, which are the x's. So you have x and y coordinates. Well, the domain is the x coordinates, whereas the range is the output of the function. Can't write. Okay, output of the function, and what's left? The y's. Okay, so the domain involves the x's, the range involves the y's. So basically, our little short, and I put little stars because this is kind of what a function is and what an easier way to think about it. So for every input, which we know that input is the same as x or domain, okay, they're all kind of linked together. For every input, there is only one output, which is the y or range. Okay? So every input, only one output. Okay? So that means if you have an x, like 5, you can only have one y that corresponds with it. You can't have 5, 1 and 5, 3. Okay? Now we're going to talk about some notations with relations. Okay? You have arrow notation. So if you were to have equation, you would say p, you have a colon, and you have of n, and then that relation is 5n minus 500. Okay? It's kind of weird. Whereas functional notation is what you are going to mostly see, but this is p of n equals 5n minus 500. Both of these are the same thing, like function, but they're just written in different notation. So instead of having the p with the parentheses down here, you have the p colon n, and then you have the arrow, and then you have the equals there. So that's the only difference. Now, so it says list the range of g of x for 4 plus 3x minus x squared if the domain is -1, 0, and 1. So we said that domain involves the x's. So we're going to find the ranges, which are the y's, by plugging in each one of our domains. So if we were to plug in, and I'm going to write it in functional notation, if I'm going to plug in -1 for my x, then that's going to equal 4 plus 3 times -1 minus -1 squared. And so then we're going to simplify that. So 4 minus 3, and then -1 squared is 1, but it's a minus, so -1, and that equals 0. Okay, so if I plug in a -1 into this equation, I end up getting a 0 for my y. Now I'm going to also do g of 0, which they asked to put in. And so 4 plus 3 times 0 minus 0 squared equals 4 plus 0 minus 0, which equals 4. So if I plug in 0, I get 4. And lastly, if I plug in a -1, I get 4 plus, or not a -1, positive 1. Okay, positive 1, then it's going to be, and then 3 times 1 minus 1 squared, so that will be 4 plus 3 minus 1, which equals 7, so 6. So therefore, if I plug in, if my domain is -1, 0, and 1, my range is what answers we get when we plug them in. We get 0, 4, and 6. So this will be my answer. Okay, the range. So it's what we put in with the x's to get out. So it says find the values of each given function with a set of real numbers as the domain. So we're coming down here. So we have our equation and we're given f of 2. So again, we are going to find what f of 2 is. So f of 2 equals 2 squared minus 2 times 2, which we get 4 minus 4, which equals 0. Plug in a negative 3, we get negative 3 squared minus 2 times a negative 3, which equals 9 plus 6, which is 15. F of 4, which is 4 squared minus 2 times 4 equals 16 minus 8, which is 8. So those are pretty self-explanatory. All we're doing is plugging in our x's and finding our y's, okay? Well, this one's a little bit different. It says f of x equals 0. So I'm going to kind of scroll this up so we can actually see what our f of x is. So what is our f of x? Our f of x is our equation. So x squared minus 2x, we said, is our f of x. It says it right here. Okay? But we want it to equal 0. So we now need to solve for this. Oh my goodness, we're solving by factoring. So our first step is we need to make sure it equals 0. And it's already equal to 0, so therefore we're good. The second step is factor. Well, we always try to factor out the GCF first. What's the GCF? I paused to see if you would actually answer. Hopefully you said x, or if you're in class, you think about x in your head. So you have x, and if you factor out x, you're left with x minus 2 equals 0. Now the second step is to set each factor equal to 0 and solve. So my first factor is x, so x equals 0. And then my second one is x minus 2 equals 0. So this one's already solved for me. And then add 2, so x equals 2. So if we want f of x to equal 0, we need x to equal 0 or x to equal 2. There you have it, folks.